This video is about expanding square roots into simple continued fractions. We'll get right to it and work an example. Let's get started. As our example, we'll expand the square root of 19 into its simple continued fraction. This table will help us keep track of things while we work. The table has a column for k, alpha, a, 1 over alpha k plus 1, and alpha k plus 1. If this seems foreign to you, please watch another video that covers the basic process of expanding numbers into simple continued fractions. In a nutshell, what we'll do is repeatedly break numbers, the values of alpha in particular, into their integer and fraction parts. So you can think of some of the column headings like this. Alpha equals a plus 1 over alpha k plus 1. A is the integer part of alpha. It's the largest integer that is less than alpha. And 1 over alpha k plus 1 is the fraction part of alpha. Then we'll take the reciprocal of 1 over alpha k plus 1 to get alpha k plus 1. We'll pass that to the next row and do the same thing. As we fill in the table, the values for a that we write are what make up the simple continued fraction. Maybe this seems confusing, but I think it will clear up as we do it. We'll start with k equals 0, and alpha 0 is the number we're expanding, the square root of 19. A0 is the integer part of the square root of 19. It's 4, but let's use this blackboard to make sure it's clear how we got that. One way is to look at the decimal approximation. The square root of 19 is about 4.4. What comes before the decimal is the integer part. So a is 4. It's this 4, by the way. Another way is we can note that 4 squared is less than 19, but 5 squared is greater than 19. A0 is the largest integer, less than the square root of 19, so same result, it's 4. We enter 4 in the table. For 1 over alpha k plus 1, which is the remaining fraction, we want the exact value, not an approximation like about 0.4, which we have on the blackboard. We can't write it as a decimal, so we'll write square root of 19 minus its integer part, which is 4. You can think of what's in the row so far like this. Square root of 19 equals 4 plus square root of 19 minus 4. Alpha k plus 1 is just the reciprocal of the fraction part, so it's 1 over square root of 19 minus 4. This is the value for alpha 1, which we'll use in the next row, but we're going to improve the form first. We'll multiply it and divide it by square root of 19 plus 4, which leaves us with square root of 19 plus 4 over 19 minus 16. In case you're wondering how we got that in the denominator when we multiplied square root of 19 minus 4 times square root of 19 plus 4, we can go over this in the blackboard. We get 19 when we multiply square root of 19 times itself, and we get minus 16 when we multiply minus 4 times plus 4. We also have square root of 19 times 4 and minus 4 times square root of 19. But these last two cancel out, leaving us with 19 minus 16. Now alpha k plus 1 is square root of 19 plus 4 over 3. This is alpha 1. We'll use it when we repeat the process in the next row. Let's do that next row. K equals 1, and alpha 1 is from the end of the previous row, square root of 19 plus 4 over 3. We need a1, the largest decimal less than this. It is about equal to 4.4 plus 4 over 3, which equals 8.4 over 3. 8.4 over 3 is 2 point something. That's more than 2, but less than 3, so a1 is 2. The remaining fraction is square root of 19 plus 4 over 3 minus 2. The common denominator is 3, so we rewrite this, but instead of 2, we have 6 over 3. This all simplifies to square root of 19 minus 2 over 3. The reciprocal is 3 over square root of 19 minus 2. This is the value for alpha 2, but let's improve the form. Multiply and divide by square root of 19 plus 2, and we get 3 times the square root of 19 plus 2 over 19 minus 4. One more time, let's look at how we got the denominator when we multiplied square root of 19 minus 2 times square root of 19 plus 2. We get 19 from square root of 19 times itself, and we get minus 4 from minus 2 times plus 2. We also have minus 2 times the square root of 19, which comes from here, and 2 times the square root of 19, which comes from here. They cancel, leaving 19 minus 4. Now, notice we have 3 in the numerator, and 19 minus 4 equals 15 in the denominator. 3 over 15 simplifies to 1 over 5, so we can rewrite the next alpha as square root of 19 plus 2 over 5. On to the next row. K equals 2, Alpha 2 equals square root of 19 plus 2 over 5, which is from the last column in the previous row. This is about equal to 4.4 plus 2 over 5, which is 6.4 over 5. That's 1 point something, so a is 1. The remaining fraction is the square root of 19 plus 2 over 5 minus 1. The common denominator is 5, so we rewrite with 5 over 5 instead of 1. We have square root of 19 minus 3 over 5. The reciprocal is 5 over the square root of 19 minus 3. Multiply and divide that by square root of 19 plus 3. We get 5 times the square root of 19 plus 3 over 19 minus 9. We have 5 in the numerator, and 19 minus 9 equals 10 in the denominator. 5 over 10 is 1 over 2, so the term simplifies to the square root of 19 plus 3 over 2. The process stays the same, so at this point I'm going to jump ahead to the last row in the table. I encourage you to try to work these rows out yourself. The results are shown, so you can check how you're doing. When we get to k equals 6, alpha equals the square root of 19 plus 4. This is equal to about 4.4 plus 4, which equals 8.4, so a equals 8. We can actually stop working right now. As we saw in a separate video, square root expansions have a single non-repeating term. It's a0. In this case, a0 equals 4. And then the expansions have a repeating part that includes terms that form a palindrome and ends with the term that is twice a0. We have this repeating part. a2 through a5 form a palindrome, 2, 1, 3, 1, 2, and a6 is twice a0, so we have the complete expansion. We don't need to complete the last row, but let's go ahead and do it and see what happens. The remaining fraction equals square root of 19 plus 4 minus 8, so it is square root of 19 minus 4. Take the reciprocal, multiply and divide by square root of 19 plus 4, and we get square root 19 plus 4 over 3. That would be our alpha if we continued and did a row for k equals 7. But look, we already had this value of alpha once before, up here when k equals 1. So if we proceeded and did a row for k equals 7, we could just copy those results. The value of a would be 2, 1 over alpha k plus 1 would be the square root of 19 minus 2 over 3, and alpha k plus 1 would be square root of 19 plus 2 over 5. Then we could pass that to a row for k equals 8, just like we did before when we passed it to the row for k equals 2. And we could copy these results. And if we did a row for k equals 9, the results would be the same as they were for k equals 3. We'd get these results. This could keep going for as long as you like. There are 6 terms in the repeating part of the expansion, so every 6th row would be the same. There's no need to keep going like this though. We can just write square root of 19 equals 4, 2, 1, 3, 1, 2, 8, with all but the 4 repeating. The numbers come from here, the column with the values of a sub k. In this video, we expanded the square root of 19 as an example of how to expand a square root into a simple continued fraction. That's all for now.